Okay, there won't be any limits on the exam. I don't know why I put this up, but I did notice I made a correction. There was another correction in here, which somebody spotted. I forget who it was. These are from last year. You know, there were a couple of boo-boos. Number 7, I think it was. Find the derivative of the sine inverse of e to the x. The solution. See how it says 1 over 1 minus e to the x squared? The square root is missing. That should be the square root of 1 minus e to the x squared. Okay? So, number 7. I'll fix that later. I haven't had a chance to go on Blackboard and fix it. Alright? I think that's all the errata for now. So, as I said before, you should be able to take the derivative of anything, and then you should be able to use the derivative. So let's do some practice problems. Dan, you had a suggestion for the class? Do you want to teach the whole class? Oh, okay. Okay. So let's see. Y sine t minus cosine t. And t equals. Was this what a sign? This is me? Why would I do that? Okay, so find dy dx. That's not so hard. You have to do that. Just do a little substituting first. Yeah. So first thing you want to do is you're going to want to substitute the t. So you're just going to want to make this sine of 1 plus cosine squared x minus cosine of 1 plus cosine squared x. You guys can do it from there. And it's just chain rules. Just chain rules. Remember, I can do these. That's why I stand up here with the chalk and make a fool out of myself for an hour and 20 minutes twice a week. I'll do this, and you guys can copy. All right? So dy dx is going to be what? Well, first we have to do the derivative of the sine of 1 plus cosine squared x. Dan thought of the problem, so it's his fault, just so you know. Actually, it's from my book, so yeah. All right, so the derivative of this is cosine of 1 plus cosine squared x times the derivative of 1 plus cosine squared x, which is, derivative of 1 is 0, 2 cosine x to the 1 negative sine x. Okay? Now I have to do the derivative of the cosine part, which is minus negative sine of 1 plus cosine squared x. And again, times the derivative of 1 plus cosine squared x, which is 2 cosine x negative sine x. And you can clean that up a lot. But you will not be required to simplify on the exam. You simplify when you need to simplify. Okay? If you want to find zeros, if you want to find the horizontal tangents, increasing, decreasing, that kind of stuff, then simplifying will help you out. But you don't have to simplify your answer. Good? All right. Speaking of tangent lines, find the equation of the line Don't worry about that. Okay? Find the equation of the tangent line to sine squared of x equals x squared plus y squared minus pi squared over 16. Don't let that scare you. At pi over 4 comma 0. Pi squared over 16 is just to make math now, right? What do you say? Are we ready? Do we need another minute, or are we ready? We're ready. All right. So first, think of sine squared x as sine of x squared. So now we need implicit differentiation, because we have our x's and y's grouped together. So we want to do the derivative. So the derivative of sine squared x is 2 sine x to the 1 times the derivative of sine x, which is cosine x. This equals 2x plus 2y dy dx. And the derivative of that annoying pi squared 16 is just 0. We don't care about that. Okay, now we have to plug in pi over 4 for x and 0 for y. Ooh, that doesn't come out well. All right, well, this problem's going to see. It's a good thing we're videotaping this, or whatever we're doing. Okay, so we're going to have a problem right here because we get nothing for dy dx. But it's a concept. I'll give you another one in a second. So, of course, you all know what the sine of pi over 4 is, right? It's radical 2 over 2. And the cosine of pi over 4 is also radical 2 over 2. So when you put them together, you get a half. So this becomes 2 times a half. You see where the problem was? I made it 0. So there is no dy dx. Okay, so let's do another one. Well, you know, that's what happens when you make them up on the spot. This time I know it'll work because I won't come up with crazy numbers. Now it'll work. Okay? So you guys know what to do. I just added another term. So we'll do this together since we just did it. All right? So I threw in the 2y term. So now if you take the derivative, you get 2x plus 2y dy dx minus 2 dy dx equals the derivative of sine squared x. The derivative of sine squared x is 2 sine x to the 1 cosine x. Now we plug in pi over 4, and you get 2 times pi over 4 plus 0 minus 2 dy dx equals 2 cosine pi over 4 sine pi over 4. So this is pi over 2 minus 2 dy dx equals 2 radical 2 radical 2 radical 2 over 2 radical 2 over 2. So you get pi over 2 minus 2 dy dx equals 1. That's not so bad. So pi over 2 minus 1 equals 2 dy dx. Divide by 2, you get pi over 4 minus a half equals dy dx the equation is y minus 0 equals pi over 4 minus a half times x minus pi over 4. Wasn't that fun? Okay? Yes? Yes? So where does 2 dy dx come from? The derivative of x squared is 2x. The derivative of y squared is 2y dy dx. And the derivative of 2y is 2 dy dx. Because anytime you take the derivative of a y term, you have to multiply it by dy dx. Yes? It's 2y dy dx. Right? The derivative of y cubed is 3y squared dy dx. Okay? Go with the dy dx term in there. In fact, you're going to see on Monday, okay? Remember, when we do the derivative of x squared, it's 2x dx dx. The dx dx is 1, so you don't need to write that. But if we were doing dx dt, you would get 2x dx dt. You would have a term there. Okay? That's what we're going to do starting on Monday, yes? This, we plug in 0 for y. So this becomes 0. Okay? Well, what's the square root of 2 times the square root of 2? 2 times 2 is 4. Divided by 4 is 1. Okay? That one's not fun. Yeah? See, where does the partial credit show up? Well, first of all, you take the derivative. That gets you some credit. Then you're going to plug in numbers and solve for dy dx. That gets you some credit. And then you're going to write the equation in line, and that gets you some credit. Okay? So that's how you would do partial credit on this. And I would weight it heavily towards the first part. All right. How about one of those logarithmic differentiation thingies that we had yesterday? All right, let's figure out what to erase. Well, I'm going to erase this. Okay. Y equals x plus e dx, all raised to the sine x. Find dy dx. How do I know that we're going to need logarithmic differentiation? Notice I have a function, and it's raised to another function. Okay? Sure. All right. That's long enough. So we have to use logarithmic differentiation here. There's 5 steps to logarithmic differentiation. Always the same 5, same order. First thing you do, take the log of both sides. The natural log of y equals the natural log of this. Okay, so that's step 1. Step 1. Take ln of both sides. Also known as log. Step 2. Okay, bring down the power. Because that's part of our log rules, our log laws that you remember from last semester. Okay? So take the log of both sides, bring the power in front. Step 3, take the derivative of both sides, and the derivative of the left side will just be a simple derivative of the log. The derivative of the right side will require the product rule. So the left side is going to be 1 over y, dy dx. It's always 1 over y, dy dx. So you take the derivative of y. On the right side, you need the power rule. So it's sine x times the derivative of log of x plus e to the x. So anytime you have the derivative of log of a function, you take the function, you put it at the bottom of the fraction, you take the derivative and you put it at the top of the fraction. Okay? Function at the bottom, derivative on top. Plus, other way around. Take the derivative of sine, which is cosine, and leave the other term alone. Log of x plus e to the x. Okay, so that's the crucial step. So you take the log of both sides, you bring the power in front, and then you take the derivative, you've got to use the product rule on the right side. Now, we're just going to multiply both sides by y. So you get dy dx. Y times this thing, sine of x, 1 plus e to the x, over x plus e to the x, that's e plus cosine x, log of x plus e to the x. Okay? And then you replace y with your original function. You put y back. Okay? Which, I'm not in the mood to write it one more time, so you're just going to replace this with x plus e to the x with sine x. So if you forget to do that on the exam, I have no idea if we're going to take off for that or not. We'll discuss that tomorrow. Professor Sutherland and I will fight that out. Yes, Dave? You have to put the brackets. Well, it's y times this whole expression. Okay? So you can use parentheses, you don't have to use square brackets, but you have to use something to demonstrate that you know that it's y times the whole thing. And then you want to replace y with x plus e to the x to the sine x. Okay? Should we do another one of those? Yes. Wow. Okay, find the derivative. All right. So step one, take the log of both sides. Natural log of y is log of 1 plus tan x raised to the 1 minus tan x. That's an easy step. Step two, take the derivative. No, sorry, bring the power in front. 1 minus tan x times the log of 1 plus tan x. Don't forget the log. Okay, take the derivative. 1 over y, dy dx equals, I use the product rule. So we could take the first term, 1 minus tan x, times the derivative of the second term, 1 plus tan x in the denominator, secant squared x in the numerator, plus log of 1 plus tan x, times the derivative of 1 minus tan x, which is minus secant squared x. Okay? How do we do on this so far? Good, bad, medium? Okay? Put y back. Y times 1 minus tan x. Secant squared x over 1 plus tan x. Plus log of 1 plus tan x minus secant squared x. And then it's too far down to write. Take y and replace it with 1 plus tan x to the 1 minus tan x. How do we do on that? Huh? Better? Darren got it. All right. How about one of those annoying tangent line through the point things, like we were doing yesterday? Okay. The tangent line 2, y equals x squared plus 2, passes through the point 2 comma 0. Find the point A comma B, which will be on the curve, where the tangent line intersects the curve. Okay, so we did a couple of these yesterday. And Wednesday also, I forget. Definitely yesterday. Which, of course, you could watch in the video, which was up at some point today. we doing on that? You ready for me? Yes? Okay. So let's think about what's going on here. We have the curve y equals x squared plus 2, and there's a point 2 comma 0. So the tangent line is intersecting the curve somewhere up there at AB. Okay? And the tangent line is going through 2 comma 0. So remember the important thing about tangent lines. There's two things to remember. One is two things about at the point of intersection. At the point of intersection, the slope of the tangent line is the same as the slope of the curve. And the other thing is that the point of intersection is the same for both the tangent line and the curve. So that point lies on the tangent line and on the curve. So if we know it's A comma B, well, we know how to find B if we know what A is, because you just take A and you plug it into the equation. Okay, if A is 5, then B would be 5 squared plus 2. If A is 10, B would be 10 squared plus 2. That's why we have equations. Once you have x, you can find y. So this is really the point A comma A squared plus 2. Okay. So now what do we know? Well, as I said, we know that the slope is the same for the curve and for the tangent line. So what is the slope of a line? Well, it's difference in y's over difference in x's. So the slope is a squared plus 2 minus 0 over a minus 2. Difference in y's over difference in x's. But what else do we know about the slope? Well, the slope is the derivative. So what's the derivative of y equals x squared plus 2? It's just 2x. So at a comma b, the slope is what? 2a. Okay? So the slope has to equal 2a. Now we can solve that equation for a. If you cross multiply, you get a squared plus 2 equals 2a times a minus 2. I'll now work over here. So a squared plus 2 is 2a squared minus 4a. Okay? Mistake? No. Oh, I'm sure it doesn't factor. In order to make it work well, I have to actually think about the numbers for a little bit. So you get 2a squared, so you simplify this, you get a squared minus 4a minus 2 is 0. And then you do the quadratic formula. A equals 4 plus or minus the square root, 16 plus 8 over 2. There's actually 2 points where this works. There's the point here on the right, and there's some point, something like that. Okay? And I don't really care what the y coordinate is, so I'd say find the point A comma B. Yeah, you have to find B. So you make the numbers work out nicely. Okay? That takes an extra couple minutes of work. It's hard to do when you're standing at the board. You got the concept? Should we do another one of these? I'll wait till everybody's done copying, then we'll give you another one. Okay. Okay. There you go. The tangent line to y equals 8 minus x squared at 2.6 comma 0. Do the same thing. time we have a curve y equals 8 minus x squared, which looks something like that. Tangent line, something like that. And that's our point A comma B, also known as A comma 8 minus A squared. So the slope is 8 minus A squared minus 0 over A minus 6. But we know the derivative is negative 2x. So this has to equal negative 2x. So cross multiply, you get 8 minus A squared is negative 2A times A minus 6. Or 8 minus A squared is negative 2A squared plus 12A. Put all the terms on one side. You get A squared minus 12A plus 8 equals 0. I told you I could make the numbers work. Sort of. Oops, no, quadratic formula. Sorry. Almost made the numbers work. So A is 12 plus or minus the square root, 144 minus 32, all over 2, and whatever. Okay? I didn't hear you, what? Can you cancel 2 and 12? No. If you wanted to simplify this, it's 12 plus or minus the square root of 112 over 2, which is 12 plus or minus 2 radical 28, 4 radical 7 over 2, which is 6 plus or minus 2 radical 7, which is 6 plus 2 radical 7 and 6 minus 2 radical 7. So you would take either one, and you plug it back into y equals 8 minus x squared, get the y value. Okay? But as I said, we'll give you an easy number if we give you something like this. I mean, maybe there won't be anything like this in the exam, and this was just a fun 20 minutes. You learned some cool stuff. Very important to learn cool stuff. But if we want to give you one, by some crazy reason, then the numbers will come out okay. I hope. All right? How about another thing? We ready? In our race? Suppose I have f of x, so y equals x cubed minus 12x squared plus 36x minus 10. Find where the function is decreasing. I don't think we really need this blackboard thing up. This isn't doing anything. Let's see. All right. You ready? Okay, these are not very hard. Get the hang of it. How do you find where it's increasing or decreasing? We're going to be doing a bunch of this stuff very soon. But after this, Wednesday we have class, don't forget. We've got all the tools, and now we're going to start learning how to apply them to a variety of problems. Okay? So very exciting. As soon as, you know, you got to make sure you have to keep all these derivatives tools. So one of the big ones we're going to do is where are functions increasing and decreasing, and where do they get maximums and minimums? Maxima and minimum. So take the derivative. You get 3x squared minus 36x plus 36. Right, minus 24x. Okay? Set that equal to 0. So 3x squared minus 24x plus 36 equals 0. Divide 2 by 3. You get x squared minus 8x plus 12 equals 0. That factors nicely. You x minus 2 and x minus 6. So at this point, you have found where the derivative is 0. We need to figure out where the derivative is negative. So when you want to do things like that, always the same technique. You're going to sign test, S-I-G-N, sign test. So you need to figure out what is the sign of the derivative in different parts of the number line. Okay? So you take a number less than 2, a number between 2 and 6, a number greater than 6. You're going to plug it in the derivative, and you're going to see if you get positive values or negative values. So you take 0, for example. That's a nice number. You plug it in here, you get 0 minus 2 is a negative number. 0 minus 6 is a negative number. And a negative times a negative gives you a positive. So the function is going to be increasing everywhere less than 2. Then you pick a number between 2 and 6, like 3. 3 minus 2 is a positive number. 3 minus 6 is a negative number. A positive times a negative is a negative. By the way, you can plug it into any of these derivatives. They're all the same thing. It's just easiest when you plug it into the factors form. Now you take a number greater than 6, like 7. 7 minus 2 is a positive number. 7 minus 6 is a positive number. A positive times a positive is a positive. So it's increasing when you're less than 2 or greater than 6. So it's decreasing when x is between 6 and 2, or in interval notation, 2 comma 6. Okay? Should I give you one more? We done for the day, or should we do one more? I heard a lot of one more. Do you want another increasing, decreasing? I'll give you a fast one. We'll do it together rather than waiting. Suppose we had something really evil like y equals sine squared x. And I want to figure out where is that increasing or decreasing. So I would take the derivative, dy dx, is 2 sine x to the 1 cosine x. And I need to figure out where is that 0 on the interval from 0 to 2 pi. Well, let's see. It's going to be 0 where sine is 0, or it's going to be 0 where cosine is 0. So that would be at x equals 0, pi over 2, pi, 3 pi over 2. Remember, trigonometry is fair game on this test. You're supposed to know your trig. Alrighty. Well, anywhere where either sine or cosine is 0. Sine is 0, it's 0 in pi. Cosine is 0 in pi over 2 and 3 pi over 2. You're not counting 2 pi. Okay, and let's say I want to find where it's increasing. So now I start plugging in numbers. So let's try pi over 4. That's 2. Sine of pi over 4 is positive. Cosine of pi over 4 is positive. It's positive. Let's do 3 pi over 4. Sine of 3 pi over 4 is positive. We're in the second quadrant. Cosine is negative, so this is negative. It's going to alternate, by the way. And 5 pi over 4 is positive. 7 pi over 4 is negative. So it's increasing, decreasing, decreasing, decreasing. Okay? And if you were to graph it, you'd see it does that. Okay? All right. That's enough for today. See you guys tomorrow. Good luck. Bye.